Okay, in number 13, we have to find the area. Doesn't say that part, but we're finding the area of an octagon with a radius that's 11 units. So what's the radius? Well, if you draw the octagon and then divided it into triangles, the radius is the side length of each triangle. So if I know it's not perfect, but that would be a regular octagon. If you drew a circle that this octagon was inscribed in, meaning like it hit all the vertices of that octagon, then these red lines are the radius of that circle. And again, they're just the sides of the triangle. So all these sides are 11. Now, and they're all equal to each other because all these radiuses have to equal each other. Okay. Now we have these 8 angles here that all have to add up to 360. So there's 8 of them. They're all equal because all these triangles are congruent by side, side, side. All those radiuses are equal, and then the triangle is also regular. So all of these sides are also equal to each other. So if you do 360 divided by 8, then you get, I think it's 135, or 45? Yeah, 45, sorry. Alright, so each of these vertex angles is going to be 45 degrees. Alright, and then if you split it like this to find the height, now this angle right here would be 22.5 degrees. So now if I take this triangle and kind of draw it so it's bigger so I could see it a little better. So like this triangle right here, I'm going to redraw it right here. These sides are 11, and then I got the height here, which gives me this angle, which is 22.5. Alright, if I call like this side X and like this part Y and that part Y, then the base of the triangle is going to be 2Y, right? Y plus Y, and the height is going to be X. Okay, so now I have to just do SOHCAHTOA to find X and Y. So I'm going to use sine to find Y and cosine to find X, because if I'm using this angle, that's going to be the opposite leg, and that's the hypotenuse. So the sine of 22.5 is equal to opposite over the hypotenuse. And then if you cross multiply, you do 11 times the sine of 22.5 on your calculator, and you get 4.209. So we'll round it up to 4.21. Alright, so that entire base is going to be 8.42 from there to there. And then the height is, you're going to do the same idea, but use cosine. So the cosine of 22.5 degrees is equal to x over 11. Now you could have also used like this leg here, which we found to be 4.21, and this leg, which is 11, and use the Pythagorean theorem to find x. That would give you the same answer. And it really doesn't matter which one you use, just as long as you get the correct answer for that height. And the height should come out to 10.16. And I got that by cross multiplying 11 times the cosine of 22.5, and then x times 1 is just x. Alright, so now the area of just this triangle is going to be 8.42 times the height, 10.16, divided by 2. Alright, and that's the area of just the triangle. So if we type that in on the calculator, we get 42.78 square units is the height of the triangle, which means that the height of the entire octagon is just going to be 8 times that, because the octagon we divided into 8 of those triangles. And that comes out to be 342.24 square units as the area of the whole octagon. In this one, you would need to answer as a decimal. There's no way to get an exact answer because we had to use trig. So anytime you do a right triangle, solve it using SOHCAHTOA, and it's not special, and you can't use the Pythagorean theorem, your answer is going to be rounded. It's not going to be exact.